Morning, everyone. I'm happy to welcome you to this year's Steminism event put on by the Steminism Press and the City University of New York. My name is Steminism Key Note. I'm the director of a new facility here at CUNY called the Advanced Science Research Center. And I'm just going to take a few minutes to tell you about that before we get started, because it's really an exciting time for CUNY in moving into this new era of collaborative research that a lot of people are really excited about, and there's good reason to be. So, CUNY, about 10 years ago, the Chancellor, then Chancellor Goldstein, decided to make 2005 to 2015 the decade of science for CUNY. And what that meant was, we're going to set aside a lot of money, $2 billion actually, and really try to target the sciences, the STEM disciplines, and give them new buildings, give them the resources they need to really sort of elevate CUNY to actually to the levels that it used to be back quite some time ago. CUNY was prolific in the sciences, winning several Nobel Prizes. And actually, just last year there was another former CUNY graduate who won the Nobel Prize. So the idea is to get back to that sense of productivity and pride, but also CUNY recognizes the importance of STEM going forward, and CUNY has a very strong presence in New York City as far as educating the city, moving the city forward, and really to be successful in the future, they need a place like CUNY to invest in the right places and really motivate the young people today to get into the STEM sciences, because that's where a lot of the jobs are going to be going forward. So the Advanced Science Research Center is really it's a state-of-the-art facility. Altogether, it's about a $400 million building. The facility that I run inside of that building is a $30 million facility known as a nanofabrication facility. So that's what we do. We design structures and simulate structures that are on the nanoscale, and we actually make them with these really high-end pieces of equipment. And the really unique thing about the ASRC is the way it's conceived and the way it's going to operate. It's really an interdisciplinary being. We want it to be a living, breathing, dynamic building where we're bringing in people from all over the world and all over the country, of all different backgrounds, put them under the same roof. There's five focus areas. There's going to be photonics, neuroscience, structural biology, nanoscience, and environmental sciences. And typically you would find these people scattered about the university. The idea is to bring them together so they can really collaborate, break down these barriers that are often there for individual disciplines. A lot of times, a person that hammers nails sees every problem as a nail, right? They often look and see from a different perspective, and often you need someone who is either from a different background, culturally, academically, to really get over those barriers. I'm a fairly young scientist, and I have in several times already been aided by people who are quite some distance outside of my expertise to help me solve a problem that I've been struggling with for quite some time. And I think that's the mission of ASRC, and we're going to be open to the public, probably starting in January is what we're looking for. We invite anyone who's interested to come over and see the facility. We're going to have an education outreach center where you can really get an idea of what we're doing and really what the field is moving towards and how you can contribute to that. So we invite you to go to asrc.cuny.edu. Sometimes it's asrc.cuny.edu. Get a look at the building. It's quite spectacular, and send me an email sometime. You'll find me under the people link there, and we'll have you over sometime. If you want to bring a class of high school students, middle school students, we welcome undergraduates. I had a fantastic conversation already with some people from Hofstra University students. And no, we're really excited. And I wanted to thank you so much for giving me time to speak. I'm going to bring up Jennifer Baumgartner, and I'm going to say that correctly, to introduce our speaker.
Hi! So, clearly Dr. Trevino and I just met today. It's like Baumgartner, feminine press, and I'm like, I'm feminine, it's also the feminist press. Feminist and feminine. I think we like masculine too. So I'm so pleased to be here. We're so happy to have this relationship the Feminist Press has with CUNY. CUNY educates nearly 500,000 people in higher education a year. Isn't that amazing? Public higher education. And I think this new center, this new institute, is such an example of the capacity that they have to kind of really make collaborative, interesting change. And I hope everybody in this room takes him up on his offer to go to the new building and see it and imagine yourself there. Imagine yourself contributing to science. So, Jennifer Baumgartner, I'm the Executive Director of the Feminist Press at CUNY. This is our 4th annual Inspiring Women Scientists event. First time we're calling it Steminism, because we thought that was funny, isn't it? And I was thinking today about how, when I was a kid, I was pretty good at all subjects except for math and science. I was just bad at them. I was just super bad at them. And I had a barrier, a block in my mind and an intimidation that it took me many, many years to realize was in some ways socialized. I wasn't scared of other things. I wasn't intimidated of other subjects that required me to learn new things. And I think one of the things that was really missing was I didn't have a teacher that modeled to me that I could be part of this, but also that made connections to my life. And it wasn't until I was in college that I took a reproductive biology class. And at that point, I was already crazy feminist on campus, and one of my big issues was reproductive rights. And this professor, male, made a connection between the politics that I was so passionate about and the human rights issues I was so passionate about and science. And it was eye-opening and kind of poignant because I realized I could have had those connections earlier. And I love what STEM is doing because it's trying to make those associative connections for girls and women, but all people, a lot earlier. And so this emphasis is really, really important, and we're really proud to be part of it. Before we go any further, the Inspiring Women Scientists Conference and everything the Feminist Press has been doing around STEM was initiated by a former board member of ours, a longtime board member. Her name is Shirley Mao. She's here. I would like to bring her up on stage. Yeah, let's bring a lot of love. And Colleen, do you want to come up too? Then we can do a little photo with the board members. Shirley, we're going to give her this citation that elucidates just a few things that she did. But among them, she developed, wrote, submitted, and was awarded 2 National Science Foundation grants for the press, totaling $350,000. Now, our operating budget, I won't share it, but I mean, that was really, really significant, massive amounts of money, and it was connecting us, the Feminist Press, the second wave institution, with something so current and so important and so future-oriented. So we are grateful to Shirley for that, and I want to award her the citation. Started a little bit late because the rain was so awful. And I have to say, when I was getting out of bed this morning, I was like, I don't even want to go. I just felt really, ugh. But the thing that got me out of bed, besides my husband turning on the lights and being like, you have to get up because you have to work, was the fact that I knew there'd be so many young people in the room. And the energy, the vitality that you just naturally bring is like, it's caffeine. I haven't even had that much coffee, but I feel really buzzed this morning. So thank you for that. And thank you for showing up on such a rainy day. And thank you to your teachers and your chaperones for making sure you came here too. We're extremely lucky to be joined today by a woman whose passion and accomplishments make her an inspiration to any young person who wishes to pursue a STEM career. Professor Yuri, who's going to be up momentarily, is currently the director of the Yale Center for Astronomy and Astrophysics, the chair of the Yale Department of Physics, and the head of the American Astronomical Society. She's held teaching positions at Johns Hopkins and MIT, and was head of the Science Program Selection Office at the Space Telescope Science Institute from 1996 to 2001. She's been honored by the American Academy of Arts and Sciences, the Connecticut Academy of Science and Engineering, among countless other institutions. Beyond her incredible accomplishments as a scholar, Professor Yuri has dedicated herself to achieving gender equity in the sciences. And in the early 90s, Dr. Yuri, along with other leaders in astronomy, held a summit that led to the production of a groundbreaking document called the Baltimore Charter. She and her colleagues present 5 premises for confronting the absence of women in astronomy careers. The Charter addresses affirmative action, family, sexual harassment, climate, and physical safety, among other issues. What makes the Baltimore Charter so powerful, and I think it's what makes feminist framing so significant, is that it calls for positive action, affirmative action. action, a recognition of the problems that exist, and a demand that they be confronted and solved for all of our betterment, for humanity. Because feminism has really benefited men as much as it has women. In short, she's a role model for any woman, girl, human being who has their sights set on the stars. So before I call Dr. Ure, I also want to identify Claudia Dreyfus, who is our friend and an incredible New York Times journalist, science writer, interviewer extraordinaire, who every year has worked with us on this event, doing the Q&A, moderating the Q&A, but also asking some great penetrating questions to set the stage. And Claudia is of personal importance to me because her work, especially as an interviewer, and including her book, Interviews, really inspired me in a lot of ways in my journalism to really approach the interview as a space of maximum truth-telling and storytelling, and I think it's influenced me as a documentary filmmaker and as a journalist, and so I'm grateful to her for what she brings today and always. So I just want to explain the schedule, and then we're going to actually hit the program. Okay, so there's going to be a keynote. There's going to be a Q&A moderated by Claudia. They'll be seated right here, kind of Oprah style. And then after that, open up to questions from the audience. I know there'll be some. And then we're going to go into our breakout sessions. You can choose wherever you want to be. There will be people at the doors who can help you select what session you want to be in, but it's also in your program, so maybe think ahead a little. And then at 12:15, we can reconvene in the main concourse to sort of network, say hello, get phone numbers, do whatever you think you need to do at that point to kind of move on. Okay, thank you so much for your energy and for joining us with Steminism.
I have to say, this is like the greatest view I could ever imagine. It's like a room full of young women interested in STEM. And I think if I blink and 10 years from now, you're all colleagues in my institution or other institutions, I'm just going to be the happiest camper. So I want you to stick with it. That's my, you know, I'm giving the talk, I'm giving the orders, you guys got it. So Jennifer gave me a difficult task today to tell you both a little bit about the science I do and then some about why I think there are so few women in science, so far fewer than there should be, and what we can do about it in particular. So let me go quickly to the science part. Can you guys read that? It's written in galaxies. That's what I worked on. Black holes. Okay, you got it. I was going to give you a hint, which is my name. I just write my name. And if you want to do this, you can just Google Galaxy Zoo spelling, and you'll get it. But you get the point. The universe is made up of lots of different kinds of galaxies. We do spirals like the one in the upper right, which is kind of like our Milky Way galaxy. That's what we live in. But lots of other kinds of galaxies, some with big bulges like the one in the center, some that are interacting gravitationally, etc. And one thing we learned not that long ago, about 15 years ago, is that every single galaxy has a very massive black hole at its center. We call them supermassive black holes because they weigh anywhere from 1 million to 1 billion times the mass of a star. And my research focuses on the black holes, when they grew, and how they got to be so big so quickly. So first I'm going to show you the best case for a black hole in this little movie by Andrea Gheza's group at UCLA. Her work of the last 25 years has been to map the orbits of stars near the center of the galaxy. Those of you, how many of you had physics? Okay, it's the most important subject, let's just say. If you've done this problem where if you have a particle, or in this case a star, orbiting something, you can deduce the mass of that something through its gravitational effect on the orbiting object. So her measurements of these stars have demonstrated that at the very center of our galaxy, in a very tiny volume, there is a very large mass. This is the best case for a supermassive black hole in the cosmos, the one in our galaxy, and that's because it's so close we can actually study it pretty well. I predict she gets the Nobel Prize for this, so keep your eyes peeled for that. Now, Albert Einstein is the guy who came up with the theory of general relativity that first created his theory predicts there will be black holes, and then everyone ignored that for 50 years, 60 years, until suddenly they appeared in nature. So I'll tell you, I'm going to teach you general relativity in one slide. How many of you have studied general relativity? Oh my God. Wow, okay. Well, I was thinking you were novices. Now you're going to catch me up. But anyway, so Einstein didn't like Newton's gravity. Newton's theory of gravity is you have two masses and there's a force between them depending on their mass and the distance. But in order for that theory to be correct, those masses have to instantaneously know about each other. Okay? And he had just finished a theory on relativity, special relativity, where the time it takes for a signal to propagate from one part of space to another is an important part of understanding physics. And so he wasn't comfortable with instantaneous information being in both places. So he reconceived gravity altogether. He decided that mass would curve space, and he was just going to talk about gravity as a curvature of space. Sounds easy. It involves something called a metric. Each kind of space has a different metric, depending on how much mass it has in it or where the masses are. And a metric is simply the distance between 2 points in the four-dimensional space-time. So 3 spatial dimensions that we're familiar with. You know, we're in 3-dimensional space here in this auditorium. And then the dimension of time as well. And you already know what a metric is because you learned, how many of you had geometry sometime? Yeah, it's got to be almost everybody. Yeah. So you learned the Pythagorean theorem, which is that the square of the two sides of a right triangle and you get the square of the hypotenuse. Now, already you have been miseducated by popular culture. Let me remind you about that. So here is Dorothy. Sorry, I gotta get this to go. Hang on. Of course it wouldn't. Hang on, I think that's the other way. Sorry, technical glitch. Let me get Dorothy queued up properly. Play automatically because for some reason it doesn't want to play on the click. Okay, there we go. And here we go.
Oh, no, my dear, I'm a very good man. I'm just a very bad wizard.
What about the heart that you promised Tin Man? And the courage that you promised Cowardly Lion?
Well, I'm Scarecrow today. Why, anybody can have a brain. That's a very mediocre commodity. Every pusillanimous creature that crawls on the earth or slinks through slimy seas has a brain. Back where I come from, we have universities, seats of great learning, where men go to become great thinkers. And when they come out, they think deep thoughts, and with no more brains than you have. But they have one thing you haven't got, a diploma. Therefore, by virtue of the authority vested in me by the Universitatis Committee Artem e Pluribus Unum, I hereby confer upon you the honorary degree of Ph.D.
PhD?
That's Doctor of Thinkology.
Some of the square roots of any two sides of an isosceles triangle is equal to the square root of the remaining side. Oh, John, that... I've got a brain!
Okay, well, that was a little bit unfair to academics, I would say. But anyway, did you hear what he said about the square root, the sum of the square roots of the two sides of an isosceles triangle is equal to the square root of the third side? Like, dead wrong. I don't know whether they did that on purpose. I went looking for this clip because I thought all these years, I thought he was reciting the Pythagorean theorem. And then I discovered that no, it was this gibberish. Which I guess is how science is often portrayed in movies. Anyway, you guys know how to do a metric.
How can I ever thank you
Sorry.
when you can? As for you, my fine friend,
He still wants to teach.
you're a victim of disorganized thinking. You are...
So let me just cheat and slip to the next one. I don't know why movies are complicated. There, go to the next slide. There we go. We're back in normal space here. So a metric is, as I told you. Now, about a month after Einstein published his paper, a guy named Schwarzschild solved the simplest problem in general relativity, which is a universe that's completely empty but has at one point in space, which they define as the origin of spherical coordinates, so r equals 0, there's the mass m. That's all there is. No planets, no stars, nothing, just that space. And in that simple picture, the metric, meaning the distance between 2 points, is a complicated expression involving distance and time. Okay? And I want you to focus on the first term, and in fact, in the denominator of the first term, which I have circled in a red box. When denominators go to 0, you have something called a singularity. The function is not defined there, which I think a lot of you probably studied back in calculus. So if we just look at that denominator, you can see that you get in trouble when r equals 0. That's why sometimes you hear a black hole is referred to as a singularity. It means that at the point where the black hole is, the space-time is undefined. We also have a special location when r is equal to 2gm over c squared. That's called the Schwarzschild radius of a black hole, or sometimes it's called the horizon. So within that horizon, the escape velocity, the velocity with which a particle or a photon would have to move in order to escape the gravity of the black hole, is faster than the speed of light. And since particles don't move faster than the speed of light, nothing escapes from within the horizon of the black hole. Now, this was all just a nice kind of theoretical thing until astronomy found these amazing black hole things in the centers of galaxies. And in order to sort of place you in the right context, I'm going to walk you through a couple of scales of space so you have a mental picture of what I'm talking about. So this is a cartoon that shows the Hubble Space Telescope in the lower right. And just below the solar panel, those two little blotches are people, so that sets the scale. Hubble is about the size of a school bus, okay, about 10 meters long. Multiply by 1,000,000, and you could enclose the Earth in a cube of that size. Multiply by another 1,000,000, and you get to the size of the solar system, 10 to the 13th meters, or about 10 light hours. It takes like 10 hours to cross from us to Pluto. I know it's no longer a planet, but you can still send light there. Now we multiply by 10,000, and we get a cube that encloses the nearest few stars. And the nearest stars to us are a few light years away. If there are planets around them, we're going to find them, and if there's life on them, we're going to find that too. Another factor of 10,000, and we get to the Milky Way galaxy, which is about 100,000 light years across. So probably filled with planets. It's got 100 billion stars, our Milky Way galaxy. And probably most of them have planets around them, and probably some of those have life. But we're not going to have, instant messaging with them. Because we send a message. Actually, we've been sending messages for many years, ever since broadcast radio and broadcast TV. So what they think of us, I have no idea. They think of the 1930s and 40s radio shows. But anyway, it'll take tens of thousands of years to reach them, and then if they're smart enough to hear it and send something back, we'll be gone and somebody else will be listening. Okay, multiply by a factor of 100, you get to our local group of galaxies. There's two big ones. It's us and Andromeda, and then a lot of little drippy ones. And then multiply by 1,000, and now you are on the scale of the entire universe, about 10 billion light years. And that is the scale where I work. Okay, I'm looking at the most distant galaxies and at the black holes at their centers. Way millions and millions of times bigger than the neighborhood we know about. My group, in the last decade, has been working on a census of supermassive black holes to find out when and where they grew. A problem that some other people thought they had solved, but we had reason to believe they had missed a lot of them. Because not all black holes, okay, I forgot to say something which I have to say because you'll get confused. Of course, no light gets out of a black hole, okay, by definition. But the region right outside the black hole is actually extraordinarily bright if the black hole is growing. Matter is trying to fall into the black hole, and it heats up and it glows. And so black holes that are actively growing are actually very, very bright. Not the black hole itself, but the environment right around it. So we've been looking for those and looking for them in special radiation, in special wavelengths where they had previously been hidden. And we use some of the most important space telescopes to do this project. The Hubble Space Telescope, I think most of you have heard of. I used to help run the telescope when I lived in Maryland. By being up in space, the skies are very dark and the spatial resolution is excellent. There's also another one you might not have heard of, the Chandra X-ray Observatory, that's very important. It detects much more energetic light, X-rays, which come almost exclusively from this black hole, growing black holes. So the Chandra X-ray Observatory is really how we spot the black holes. And then there's the Spitzer Space Telescope, which looks at infrared light and finds thermal emission, re-radiated emission from dust that has absorbed the optical light that we in fact don't see. And we also use ground-based telescopes. These are the two Keck telescopes in Hawaii on the summit of Mauna Kea. You should go out and look at them if you're ever in Hawaii. And we use all of them put together and then some in order to do our research. It's really a terrible job being an astronomer. You have to go to Hawaii. And actually, we don't observe from the summit. It's 14,000 feet, so you quickly lose oxygen and you become dumb. So they don't let you observe from up there. You have to observe from a town that's a few miles away. So not only are you suffering in Hawaii, but you, in the middle of the night, can suffer by driving to the Starbucks or going to a restaurant and having dinner. Okay, so the big survey that I designed is called GOODS, the Great Observatories Origins Deep Survey. Great Observatories are what NASA calls its major projects like Hubble, Spitzer, and Chandra. And deep survey because we took the deepest picture ever taken of such a large area. It's like a quarter of the size of the full moon. Huge survey for compared to previous work. And we added origins because without it we looked very arrogant. Personally, I argued for it, but no one listened to me. Okay, so this is the picture you're looking at, which you can look. I wish you would look at online sometime where it's really dark because it's just spectacular detail. You're basically looking at 200,000 galaxies in this image. And if we look at a tiny piece of the image, whoops, sorry. This is a tiny piece of that image that you can barely see from where you are. And all I want to point out is those three circles tell us where the black holes are growing. They're in the galaxies inside those three circles have very active black holes because they give off X-rays. The one in the white circle on the right is an unobscured, we call them quasar, unobscured quasar, and you can see the optical counterpart is pretty bright. In the other two, we know from the X-rays that they are probably obscured by gas and dust, so they don't shine in the optical, and these are the ones that had been missed previously. And now we look in the X-ray, we see strong sources, and if I add the infrared, which I do here, we see strong infrared radiation. And a pile of students did very quantitative analysis of all of these data and showed that previously people had missed about 3/4 of all the black hole growth in the universe. So it was kind of exciting for us to find. Right, and also just to say, we live in a really boring neighborhood. We're in the outskirts of our galaxy, and our galaxy and other galaxies today are not doing very much. This is good because X-rays are not good for human health. So if we have an actively accreting black hole, we have a black hole, but it's not active. We might be a little more, have shorter lifespans, let's put it that way. Okay, so I'm going to show you one movie that just shows two galaxies interacting. This is a computer simulation of two galaxies. And it stops to show you real galaxies that we see in the sky. The computer simulation represents about 200 million years of elapsed time. So we never see this happening in real time, but we see images that look like parts of this simulation. So there's a real pair of galaxies that are in the middle of a gravitational interaction. And as the interaction goes on, you see these very long, what are called tidal tails, which are caused by the gravity of each galaxy on the other one. Because they're close relative to their size, the near side pulls on this galaxy harder than the far side, so it stretches the galaxies out. And you can see that we have many examples of these kind of interactions happening. And so we have a good idea of what's happening over cosmic time, and that's another piece of what my group works on. Okay, I'm going to go on. All of these are available online. And now I'm going to switch gears. Okay, so I'm really lucky that I get to be paid to do a job which is basically really, really interesting and fun, finding out how galaxies form and how black holes grow. And I guess along the way I teach physics to undergraduates. So I got my PhD in 1984. To you that sounds ancient, but to those of us who are your age in the early 80s, we thought feminism was unnecessary. Not that we weren't feminists, I mean I certainly was, but just we thought that the reason there were no female professors in our universities was because they didn't want to be professors before feminism, and now they did, and we just had to wait. And we thought that we would have no trouble being treated fairly in the workplace. In fact, I was frequently told that in fact I would have a much easier time than any young man because universities were being forced to hire women. How many of you have been told that you have an easier time because you're female or because you're a minority? Yeah, I'm here to tell you it's untrue. And I saw this over many years, watching what happened to female colleagues, watching female colleagues underestimated. It's a little hard to see it happen to yourself, but it's easy to see it happen to your colleagues. And so in 1990-ish, 92, we held the meeting, the first meeting on women in astronomy ever, and that was the start of the revolution and the start of, well, I guess my involvement started a little bit earlier when some guy told me that so-and-so got her job as a faculty member because she was a woman, that the dean had insisted the university interview her and then insisted they hire her, and she wasn't nearly as good as the man for whom that job was intended, blah, blah, blah. And this was devastating to me. I was a postdoc at the time looking for faculty jobs, and I thought this was truly terrible. So but I found out about a year later when I talked to someone who was actually on the search committee for that position that it was all bullshit what he said, pardon my French. And then in fact, she had been invited, she'd given an amazing talk and blown them all away, and she was the best candidate, and that's who they hired. And that's when I started thinking, okay, all is not as it seems or as I'm being told. So let's very quickly look at some statistics, and I'm just going to run through these fast. This is the fraction of degrees going to women. All these plots are the same fraction of degrees going to women. This is over a 20-year period from 1991 to 2010. And what you see in the different colors are bachelor's and master's degrees with PhDs at the bottom. So the blue and purple at the bottom is PhDs in social sciences and biosciences. And you can see that women are basically near 50% or just a bit above these days in getting PhDs, and have always been above 30% the last 20 years. They are not above 30% in the hiring in those departments, I will tell you. Mathematics and physics are lower. The PhDs, again, are at the bottom. Physics and mathematics are sort of have over 20 years gone from 20 to 30%. Physical sciences. The only reason physical sciences looks halfway decent there is chemistry. These are the numbers for chemistry, and the number of students in chemistry is large. If you were to plot physics, you would just take that line and move it down by more than a factor of 2. And engineering, too. Here's the engineering degrees. You can see that women are below 20%. In the PhDs, they're down around 10 to 20% over this time period. And here is now the scale has changed. It's 20%, because this is so small we can't even plot it on a 100% scale. These are the percentage of bachelor's degrees going to underrepresented minorities who are women over that 20-year period. You see that it's very low. You see that engineering and physical sciences are near the bottom. And this is now still for underrepresented minority women, doctorates, masters, and bachelors in all STEM fields. They're very low, below 5% for the PhDs. And this is not because of a lack of talent or a lack of perseverance or a lack of interest. I'm going to, in just a few minutes, tell you what I think it is. Oh, right, very quickly. Attrition. This is bachelor's degrees in different fields. This is PhDs. I give a 7-year gap from one to the other, and then let's look at the attrition. Here's the bachelor's degrees in 1977, and then PhDs in 2004. In all fields, it goes down. In math, it's cut in half. In chemistry, it goes down. And in physics, it goes down a little, but physics is at the bottom. Not good. Okay, we are training people that we are then allowing to leave the field without using their training. Okay, why should we care? The number one reason is excellence of the field. If we have omitted half of the population, we have basically dipped deeper in the talent pool of white men, and so we are not using all the brains that could be used on a problem. And it's also true that diversity improves innovation, so we need that in science. Also, just a matter of fairness, I think that's what drives me. I see a lot of young women really keen to do science, and they get been drummed out by bad attitudes, and I'm irritated about that, and I'm going to fix it. It's also a great life. If we are well supported, our salaries are good, it's relatively easy to have a family and be a professor, and taxpayers don't look like the professors in universities. The professors in universities are overwhelmingly white men, and the taxpayers are a beautiful mix. I would also say it's unhealthy to have such a small group sort of own the profession. It's not good for society, and it's not good for science. And of course, there are workforce issues as well. As we move forward into the 21st century, the amount of science and technology that is part of our daily lives is just always increasing. Take climate change, good example. I won't go there. Okay, I'm going to just not defend this slide for the moment. Please ask me about it. And why are women falling behind? There are lots of people who opine about this, like former president of a famous university, for example. But there are data, and as scientists, we should look at data and ask, does your hypothesis work? So, for example, it's not that women aren't as good, number one. Number two, it's not that they're not interested or making the effort. It's certainly not family. I'm happy to expound on that later. And it's not anybody saying, I don't want women in my field. It's not, very rarely do you get this kind of conscious discrimination that did happen, frankly, 30 and 40 years ago, but it isn't happening now, to my knowledge. Or not in front of me, that's for sure. They take their life in their hands. Okay. So here's why it is. It's something that Virginia Valiant, in her wonderful book, I encourage you to read. Oh, I should have said, there's a reference here, sorry. Beyond Bias and Barriers, 2006, National Research Council. You can get it online in a PDF file. It goes through these things in great detail, and Larry Summers should have read it. I just did not read that. But Virginia Valiant's book, which was written in 1999, that is a wonderful summary of the issues. Basically, women in male-dominated arenas are people have lowered expectations of them, and they evaluate them lower than men of comparable achievement. And I'm going to just very quickly show you a few pieces of evidence for that, and I hope you'll explore more. Virginia Valiant really has worked a lot on this. So I'm going to tell you about a couple of experiments, and these experiments all involve resumes, the ones I'm going to talk about. They're very clean, so you calibrate. First of all, the experiments are usually done on undergraduates who take a class. So they're young college people. And you can calibrate the resumes. You can give people an all-male suite of resumes and calibrate what they think of these people without the gender being part of the equation. And then you can put the gender in, so you have resumes that have a man's name or a woman's name, and then you can see how the result changes. And let's see, I think I'll just mention one of these four experiments. Porter and Geist, leaders at a table. The subjects of the experiment, the undergraduates, are shown a picture of people sitting around a table, and they're asked to identify the leader of the discussion. When the only men are sitting around the table, they identify overwhelmingly the man at the head of the table as the leader of the discussion. When men and women are in the photo, and a man is sitting at the head of the table, again, they identify him as the leader of the discussion. But when a woman is sitting at the head of the table with men at other positions around the table, half the time the respondents will identify a random man as the leader of the discussion. Even if the woman has a pile of papers in front of her that makes it clear she's in charge. So women are not seen as leaders. You are not seen as leaders in fields where there are not abundant numbers of women leaders today. Let me give just one of these. There are thousands of these studies, and they all kind of go in the same direction. But I'll talk about Ullman and Cohen in 2005. But I think Cohen was at Yale at the time he did this. Shifting criteria. So they looked at applications, resumes that were supposedly for a job, either in nursing or in being a police chief. And before the subjects saw the resumes, they were asked to write down what's important in hiring for this position. And so, for example, for a police chief, you might check off physical fitness, big, has a deep voice, previous experience as a policeman. And for the nursing supervisor, you might check off the more stereotypically female characteristics of nurturing, caring, has been a nurse before, whatever. Okay, talking just about the police chief one. If the resumes are all men, they pick out the man who's most qualified by those criteria that they ticked off. However, if a woman has that resume with the former experience as a policeman, she's big, she's strong, she goes to the gym every day, whatever, they don't pick her, they pick some man, even if he has the sort of nurturing qualities that were not deemed to be important for selecting a police chief. And what's most interesting about this study, the reason, I mean, there are many studies like that, the reason I'm talking about this one is they also asked at the very beginning, are you objective? And the people who said they were objective were the ones most likely to switch criteria. So they put down the things they thought were important for a police chief, and then when a woman's name was on that resume, they switched and picked the man with different qualifications. The people who said they were not objective were much less likely to switch. So self-awareness, awareness of one's own lack of objectivity, which by the way is shared by men and women. This is not something men do to women, it's something we all do to applicants for jobs and students and everything else. Okay, enough about that, that's an important one. And there are many, many interesting studies like this. So I'm going to skip on, except to say, Virginia Valley has a very nice annotated bibliography describing many of these studies. If you're interested in following up, you could just Google her, Virginia Valley Anthropology. Okay, I'm going to talk about one more study because it really hits us where we live. Joe Handelsman, who is now deputy to the Presidential Science Advisor in Washington, on leave from Yale, was a biology professor at Yale. And she, like me, has given many of these talks about women in science, and she says she always gets the same reaction from scientists, from her science colleagues. They all say, well, come on, you know, those questions are being asked of undergraduates, and that's not us. We are scientists. We were trained to be objective. We are, you know, we are not biased. That is what all of my colleagues tell me. We are not biased. So she decided to do an experiment on men. She sent resumes to 120 some professors in 6 universities, 3 public, 3 private. Half the professors were women, half the professors were men, which means she had to work hard to get the women, because there aren't as many women. And then she sent them each one resume, which was of a college senior who was purportedly looking for a job as a lab manager. And the only difference in the resumes was some of them had the name John somebody on top, and the other had the name Jennifer somebody on top. And the people who got these resumes were asked, would you hire this person? Would you mentor them? And how much would you offer them? The story they were told is that this is one of our seniors, we're trying to give them advice, could you give us some feedback? Okay. So what happened? Well, both men and women saw the male candidate as more competent. Remember, they're identical. I mean, they weren't comparing, right? It's not like you had 2 identical resumes, one says John, one says Jennifer. You only get one, and you may get the man, you may get the woman. They were more likely to hire the man, they were more likely to mentor the man, and, not surprisingly, they offered him more money, average of $30,000 a year compared to her $26,000. So this was done by scientists about science. So let's not pretend that we are any better than everybody else. If you want to check yourself out, I highly recommend this website, implicit.harvard.edu. How many of you have done it? Some of you. Mazrin Banaji was a colleague at Yale when I first moved there in 2001. And Harvard stole her, but that was good because she was one of the people who helped Larry Summers get smarter than he is. And I'm going to skip this one, but it's cute. And I'm going to talk about, do you guys know about stereotype threat? Just tell me. Yes? Not many. I got to tell you this one then. Stereotype threat. Performing below your ability because of a stereotype. So a group of students is told they're going to take a very hard math test. And they do. And the men score a low, 25 out of 100, but the women are much lower, 10 out of 100, 10 points out of 100. So you could stop there, and the New York Times could write a front page story saying, or Larry Summers could say, women aren't as good at math at the, at the high end. But instead, what these researchers, led by Claude Steele, did was repeat the test, only they put a sentence on it. This test was designed to be gender neutral. And lo and behold, the women's score doubled. And the men's score went down. So now men and women perform the same with no change on the exam, just on the mental picture they have before the exam. This has been repeated. It is highly repeatable. You can make things worse by saying to your freshman class, oh, I see a lot of women here today in my physics class. Women don't do very well in physics, but maybe you will, right? If you did that, you would automatically guarantee your women students would perform worse. It also applies to stereotypes related to race. So very important, and very important that we understand that some of these so-called measured differences are not really somehow intrinsic. Okay, I'm going to close my talk with 11 steps to success for young women. A recipe. Here's your recipe. 11 things to do. So first, the most important thing in science is to work hard at something you love. You want to pick something you really enjoy, and believe me, it doesn't feel like work. It's what you want to do. It's what's interesting. It's one of the many things that you might find interesting. It has to be interesting to others and of high impact. And if it is, you will be successful. The playing field, I believe, is still currently uneven, but if it is, don't be discouraged. You can outsmart them. Because you're armed with this knowledge, you can avoid the discouragement that would come your way if you unthinkingly imagined that it was an even playing field. I can't tell you how many times I've said to a colleague at some department that has 0 women on its faculty, have you thought about, hiring any women faculty? Oh, yes, we really want to hire women, but we want to hire the best. And I think to myself, excuse me, that's not really different. Like, hiring women is not different from the best. In fact, if they thought about it, they'd realize because they've only hired men, they're not getting the best. Because there's a lot of great women out there that they're missing. But they have not, most of my colleagues have not evolved that far, I would say, to realizing that. And they will talk about how, in fact, recently, a colleague in economics said to me, he was all excited to tell me this because he knows I'm an activist. He said, you're really going to, we really try hard to hire women. Of course, there aren't any who are good enough, so we just lower our standards to hire women. Swear to God, a year and a half ago. So I said, well, I doubt that's necessary, but anyway, okay, feet up. Mentor each other, okay, help each other. And there were some pioneer women ahead of me, but much of the support I got came from peers. Network with your friends and allies in science. If you find yourself in a department as the only woman or in a research group, find somebody in another research group or another department. Networking, I think, has been the single most effective way for women to keep themselves in the game and keep moving forward. This is my personal bugaboo. When you are in a professional setting, which is everything that's not a party in your college, okay, please introduce yourself with 2 names. My name is Meg Yuri. Pause, because you got to make sure everybody hears your name. Your last name is your professional identity. So if you're at a meeting and you don't say your last name, you don't know if they've read your paper. Okay? So first and last names, and also you look serious. We had a job candidate who once came and said, hi, I'm Lindley. I'm like, no, that looks like, hi, I'm, trying out for secretary. I don't know. It was not professional. You got to be professional. Okay. Prepare an elevator speech. That means a very short speech saying who you are. My name is Meg Yuri. I do research on supermassive black holes in galaxies and teach at Yale University, and I'm an activist for women in science. Something brief enough that people know who you are from your way of telling them. It also makes you look really professional. Shake your hand, 2 names, elevator speech, you look great. Practice confidence. How many of you feel supremely confident? I thought there'd be a few hands, but there aren't a whole lot. How many of you feel you are imposters and you just wait until they find you out? Confidence is a huge advantage in any endeavor. So I think you should practice being confident. Fake it till you make it. Okay, so at night when you're brushing your teeth, look in the mirror and say something that is true, that is positive about you. You can say, I had a really great idea today, or I nailed that exam, or I was, or I did something else. Just give yourself a boost. Most of us focus on the negative. Somebody said something negative about me, and that can last a month. You can think about that for a month. But we forget the good stuff. So tell yourself something good every night. Give great talks. Even if you don't give great talks now, you can learn how. And own your ambition. I am so disturbed to find young women who are discouraged from showing how ambitious they are. That is, to call a young woman ambitious is a bad thing, almost. Whereas, of course, ambitious men that's normal. So own your ambition. If you want something, don't apologize for it. Try to go get it. And that's my biggest message for you. Go get it. Thank you.